Hi, I'm Brad Wilson with EMC. I'm part of the Office of the CTO, responsible for telco transformation. We're going to be talking about our new Provider Cloud solution today, as well as showing two demos. Telco Transformation Group was started about 15 months ago within the Office of CTO to really start understanding, as EMC as a federation, how to leverage the existing EMC assets to be relevant to the engineering groups and the network side of the telecom companies. So part of telco transformation is to understand the requirements and start being able to talk their language, being able to articulate how our solutions can be relevant, and more importantly, start collaborating and build new solutions. So perfect example today is Provider Cloud. Provider Cloud is a reference architecture, allows us to take NFVi type workloads and put it on our technology, but more importantly, start addressing the technology across the carrier so you can start moving multiple workloads onto a consistent hardware architecture and software framework. Additionally, we're also being able to build a new ecosystem. This is a really important part of what we're trying to do today, and we have about 8 demos here. We're going to focus on 2, but those demos are showing us leveraging VNF providers, creating new ecosystem, showcasing what we can create going forward in the areas of IoT. So as you talk telco transformation, there's a number of moving pieces within the EMC Federation that come together to create real solutions that are relevant to our provider customers. We hear a lot of providers tell us, as a federation, you bring a number of assets to the table. They're coming to us to see how we can leverage those technologies for that. So as we go forward, I think you'll be very excited to see what we can do that's interesting, unique, and different. So a perfect example is we're going to showcase the affirmed VNF. It's a VNF running on top of our architecture, but more importantly, we're able to, with that VNF, leverage the ability to do virtual embedded probes and stream data off. Instead of having passive probes, you're now being able to create new economics, leveraging virtual probes to take that data off the network and create new use cases, from footfall to revenue to network operations. So as you see going forward, as we build these applications, we're going to start creating time to market improvements. We should be able to load up a new VNF in hours, launch a VNF. If the service is not successful, take it down, have minimal impact on the operations. So those are the type of opportunities we see going forward with NFVi, and all of those NFVi VNFs will sit on what we call Provider Cloud platform. The affirmed is an interesting use case as well, because we are showcasing the ability to take that VNF and load it very quickly. So you'll see us on the Provider Cloud. It'll be one of our first VNFs in our reference architecture, so that's affirmed. We'll also be showing a virtual CPE use case using Versa. Again, allowing us to create a new ecosystem partner to create new use cases that are cost effective. The biggest challenge for the telcos is to drive costs out of the business, to be dynamic, to create new revenue. The VNFs from Versa allow you to create a new price point that's very much lower than the traditional solutions, and we can deploy in significantly less time than we would with the traditional providers. So you're going to see a number of different VNFs as we go forward. We're going to try to foster that ecosystem. We believe that if EMC, we can help foster new providers, that'll be good for the market. The best part for us is if we create many VNFs. As you'll see with VMware, I think we're announcing over 50 VNF providers that are working on top of the VMware technology. So as we create that ecosystem, we help certify those providers, it all makes it, de-risks it in the industry. So very important for us is being able to create an ecosystem, be able to create new cost economics. So when we look at the PCS architecture, we think of it as taking it and combining the DevOps mentality with the carrier grade, combining those to create new architecture, new way of doing business. So it's blending the IT world, the DevOps mentality with the carrier grade telco mentality. That's some of the things that we're looking to do as we go forward with these reference architectures. We also believe as we start building these ecosystem, new use cases will come out that are very critical. I'll give you an example. We have one provider in Asia Pac that launched an application to lower the amount of rebates they're giving their end providers. And they're doing that because that's saving $10 million that they want to cut in their costs in rebate checks. So it's about us being able to leverage these tools for the business users, creating new relationships with those business users. We're working with some customers in Africa to actually improve the way they do campaign management by leveraging real-time analytics. So again, most of these are about us using or leveraging the network technology with the analytics or the IT environment to really create effective use cases that are going to impact the business. And that really is about time to market, being able to be more elastic in our ability to expand and contract based on workloads. You'll see in some of our demos, we'll actually show building up an NFVi environment, a separate cloud environment, and maybe even have a hosted environment, and being able to match those workloads based on usage requirements. So that's the type of environment we want to move forward in. That's the type of environment that these tools will allow. So PCS will allow us to operate a standardized offering across multiple workloads. We have real-time analytics that allows us to start doing network analytics with subscriber and mixing them to create new use cases. And you'll see us add things like Internet of Things. We have a proof of concept over here around different use cases we're doing and different partnerships we're doing in the Internet of Things. You'll also see, as you go around this booth, you'll see a number of different federation components. You'll see VMware, you'll see Pivotal, you'll see VirtuStream. It's about the federation and leveraging those assets to be effective for what a carrier goes forward in their business model. Because you know most of our big customers have a hosted environment. They're now looking at cloud. They're now looking at how they take those same environments and start moving NFV workloads on top of that. And we see that from carriers worldwide. Okay? So as we start going into the demos, I really want to showcase, in particular, the Affirmed use case, because we think this really shows the perfect matching of taking the VNF technology that's virtualized and start building in the analytics that allow you to do new and interesting use cases. So with that, I'm turning it over to Mark to go into the Versa virtual CPE use case.
Hi, my name's Mark Byerl. I'm also with the Office of the CTO at EMC, working on the telco transformation. I'm here doing a demo today at Mobile World Congress. We're going to be showing the EMC Provider Cloud Systems, showcasing Versa VNFs over top of our environment. The whole concept of the demo and the Provider Cloud System is that we can go right from bare metal environment and automate the installation and configuration at the hardware layer, go ahead and lay down all of the software for the VNF management, as well as the full VM orchestration environment. So it's a composable architecture. We've got various different hardware vendors that can be used from the switches and the bare metal servers, as well as different cloud management systems. So we can go from the bare metal servers, lay down the operating systems such as ESX as a hypervisor, put down the vCloud Director or other management software around that, as well as using things like vRealize from VMware to do predictive analytics. We have an NFVi manager, which is an automation engine, which helps control the entire environment. It allows for feedback from the environment, from the collection of telemetry, to come into it and to help deal with the scenarios and remediation that comes up. Layered over top of all of this, we have chosen to work with Versa in this particular implementation. Versa is being showcased as the VNF provider. So Versa Director and Analytics are being put down on top of the entire layer, and at the end of the automation, building up the entire stack from the bare metal all the way through to the Versa layer, you're left with a complete VNF workload ready environment. And so you can go right to the Versa interface and pre-provision your SD-WAN or next-gen firewall or whichever vCPE it is that you happen to be needing for the environment, and it just plugs in, can be turned up in a matter of minutes at this point. As well, with everything having telemetry being collected from all the layers, including the Versa layer, we're able to do true cross-domain root cause analysis. So say something as simple as a port failure on a switch occurs. You can get alarms all the way from the VNFs themselves saying we've lost contact with our peers on a network in an SD-WAN environment, all the way through the hypervisor saying, hey, I'm no longer able to talk to this particular VM, down to the hardware layer saying we've lost the port switch. And we're able to do the full root cause analysis on that and silence all of these alarms and drill down to the simple issue of what went wrong, that being the port failure.
Hello everyone, my name is Dan Leskarowski. I'm a product manager with Affirm Networks. I'm here today to talk about a new innovative product that Affirm is introducing. The name of the product is Intelligent Virtual Probe. And what makes this product unique is that the actual functionality of the probing is integrated within the application. Affirm offers a variety of different VNFs, both on the 3G, 4G side with P gateways, S gateways, as well as on the Wi-Fi side with ePTG, TWAP, and TWAG. And within each one of these VNFs, the virtual probe is integrated and it's part of the application. So before we get into the functionality of the vProbe, some of the market drivers of why we decided to actually go down this path. There's really three key things that are driving this development. One is scalability. As operator networks continues to grow in throughput and the data usage per users continues to grow, there is a challenge of keeping up with the need to actually deploy additional vProbes to troubleshoot and support the network. So there is a need for a more scalable, more intelligent way of actually being able to packet mirror and support the data. Real-time monitoring and troubleshooting. A lot of times real-time monitoring is very isolated to a small subset of users. What the Affirm vProbe with a partnership of EMC does, it enables the real-time troubleshooting of all users at all time. A very, very important differentiator in our product. And lastly, which is very, very important, by moving into a virtualized network, what happens is that the demarcation points or the insertion points of where physical or traditional probes can be inserted disappears. And what I mean by that is that in the past, every single network entity, being a S gateway, P gateway, a proxy, were standalone entities, and a physical probe can be inserted in each one of those points. By collapsing the architecture in a virtualized network, those insertion points disappear. So there's truly a need to have probing on the application itself. And one of the coin words out there is it's called self-probing, or having VNFs that can self-probe. The last thing I'm going to say on this slide is, as VMs move from one place to another, or as a cluster increases in capacity, the traditional probes are not very well suited to actually move together with the VM because they're physically connected to the hardware. So I kind of touched up a little bit on this. Legacy probes, they are usually tied up to a layer 1, layer 2 type of product connections, so they're very hard and not very robust when it comes to moving. Even with current virtualized probes, they're very passive. And what that means is that the information they receive is 100% of the information. So they have to process all the information that is being passed through the application. The passive virtualization probe will have to do the same thing. With the native or integrated solution, the probe is part of the application. And because of that, you actually have the luxury to pick and choose exactly what type of information you need to provide for troubleshooting, and more importantly, you can actually correlate both control plane and user plane data into one. And lastly, from a functionality standpoint, there's 3 different feeds that we provide to the analytics portion. In our case, it's EMC and their RTI tool. We have something called Intelligent Event Data Records. These are flow-based, very granular user records. They collect all the information from a data perspective, both on the control side and on the user side, and it's very easy to have a real-time snapshot of the overall network intelligence. In addition to that, we have both control plane and user plane packet mirroring, more of your traditional way of doing things, except now in the application layer. You can packet mirror control plane, either all control plane messages or based on a particular interface or protocol. And on the data side, we give you the option to data packet mirror based on particular IMSI range, IP address, APN. This allows an operator to actually skin it down and narrow down how much data they have to packet mirror. And that's all I had. I think now Eric will talk about the analytics part of this, which is the RTI tool and how the data is actually received and parsed and provided by EMC.
Hi everyone, my name is Eric Caron. I'm with EMC as part of the Open Innovation Lab. So today I'm going to talk about the Affirm and EMC solution. As Dejan mentioned briefly before, as we look at the screen here, we have the Affirm solution sending the EDR's record to the EMC solution, which is capturing the information in real time, and then it's also able to filter the information, to anonymize sensible fields, and on top of that, in real time we can calculate analytics, simple analytics, and then deeper analytics to do like more analytics over time. Now, if we, one thing I want to mention is that the RTI platform has the different SDKs that you can use to leverage information from different sources. In this case, it's Affirm, and we're giving access to customers to be able to customize things in the platform. So now here, if we look at some real-time use cases that we've implemented with Affirm, we can see here that we're monitoring the traffic bandwidth on the network per different network devices. And then what we see here, we're monitoring the bandwidth, and we have a threshold where it's showing up a warning there. And this type of stuff can be used to send SMS, can be used to send emails or alarms, but also can start, like if it's an issue for a subscriber, we can start a packet capturing through the VEPC. So that's one of the use cases. But the point I want to get across is that we can do that all in real time. So as the traffic is going through the network, we're kind of able to show the information to the administrators and take actions in real time. So here, in this use case, we're showing similar information where we're showing the bandwidth calculations, but here it's per EPN. What I say EPN is it's an enterprise customer like Coke, Pepsi, UPS, and here you can see a view of the bandwidth for those enterprise customers. So here, a different view here, a use case where the traffic is flowing in real time and where the RTI product is calculating the top 10 URLs in terms of it. So it's always good to have a view of which are the websites are the most popular on your network. So another use case here where we're calculating the average latency or the worst average latency for the websites on the network, and this information is updated really in real time. So on top of real-time use cases, we can do also historical use cases. As the information is processed in real time, it can be written to a data lake, and the information is stored there for a month or a couple of months, and based on that you can have different use cases. So what we're showing here, with the information stored in the Hadoop system, we have different reports using the Tableau software here to show that we have a top 10 list of URLs on the network, and it's based on the date, and it's also based on the hour, and that hour we have the distribution of the URLs on the network. And then here you can have more or less URLs in there. So here we can see that you can drill down to have more information about the traffic, who has generated this traffic for that URL. One of the use cases based on the historical data is the web experience. So you can see that the subscribers are, based on the latency and the criteria, you can see that there's different ratios, and you can see the percentage of users that are getting a good experience and a not so good experience, and based on that ratio. As you can see here, on different dates and minutes, there's those different ratios, and you can filter out per date, per hour, minute, and also the criteria here. You can change this, and it's going to change your calculations. Thank you, everybody.